Right, so here we're going to talk about um, aerodynamics and a little bit about flight. So in this presentation, we're going to learn a little bit about the atmosphere, the structure, pressure, density, aerodynamics, a bit of introduction into it, and four forces of flight, theories for flight, which is Newton's laws of motion, Bernoulli's principle, airfoil, equilibrium, and three-dimensional movement. To begin with, we have the atmosphere. The Earth's atmosphere is a layer of gases which are commonly known as air. These layers surround the Earth and are retained by the Earth's gravity. It's a mixture of gases composed principally of nitrogen and oxygen. Structure of the atmosphere. Air pressure and density decreases with altitude in the atmosphere. The temperature here has a different and rather complicated profile. It could remain relatively constant or increase with altitude in some regions. The Earth's atmosphere can be divided into five main layers: exosphere, thermosphere, mesosphere, stratosphere, and troposphere. The exosphere is the outermost layer of the Earth's atmosphere. This layer is composed of extremely low densities of hydrogen, helium, and several heavier molecules including nitrogen, oxygen, and carbon dioxide closer to the exobase. The and molecules of this layer are so far apart that they can travel hundreds of kilometers without colliding with one another. This makes the exosphere to behave more like a gas, and the particles constantly escape into space from this layer of the atmosphere. Meteorological phenomena are possible here since this layer of the atmosphere is located too far above the Earth. Thermosphere. It is the second highest layer of the Earth's atmosphere. Since the pressure in this layer is lower than usual and the air is very thin, an individual molecule travels an average of 1 kilometer between collision with molecules. The temperature in this layer increases with height. This layer is completely cloudless and free of water vapor. The International Space Station orbits in this layer. The mesosphere. This layer is the third highest layer of the Earth's atmosphere. It occupies the region above the stratosphere, below the thermosphere. In this layer, the temperature drops with increasing altitude to the mesopause that marks a missile layer of the atmosphere. It is the coldest place on Earth and has an average temperature of negative 85 degrees Celsius. The mesosphere is also the layer where most meteors burn up upon atmospheric entrance. It is too high above the Earth to be accessible to jet-powered aircraft balloons and too low to permit orbital spacecraft. Stratosphere. This layer is the second lowest layer of the Earth's atmosphere. The atmospheric pressure at the top of this layer is roughly 1,000th the pressure at sea level. This contains the ozone layer. The stratosphere defines the layer wherein the temperature increases with increase in altitude. The rise in temperature is mainly because of the ultraviolet radiations from the sun by the ozone layer, which restricts turbulence and mixing. The stratosphere is the highest layer that can be accessed by jet-powered aircraft. The troposphere. The troposphere is the lowest layer of the Earth's atmosphere. This layer contains roughly 80% of the mass of the Earth's atmosphere. It is denser than all its overlying atmospheric layers because a larger atmospheric weight sits on top of the troposphere and causes it to be severely compressed. Almost all the water vapor or moisture is found in this layer. Therefore, this is where most of the Earth's weather takes place. Most conventional aviation activities takes place in the troposphere. There are other layers. The few other layers that we have are the ozone layer and the ionosphere. The ozone layer is a layer that is contained within the stratosphere, and the ionosphere is the region of the atmosphere that is ionized by the solar radiations. Pressure. Atmospheric pressure varies with altitude. The higher an object rises above sea level, the lower the pressure that it experiences. Density varies directly with pressure and inversely with the temperature. In the atmosphere, air density decreases as altitude increases. This explains why airplanes have a flight ceiling an altitude above which it cannot fly. Let's talk a bit about aerodynamics. Aerodynamics is a branch of dynamics that deals with motion of air and other gaseous substances. It is the way air moves around things. It is the rules of this theory that explains how the airplane gets its ability to fly. As we all know, there are four forces that act on a flight. The four major forces are lift, weight, thrust, and drag. These forces are what makes an object move up and down, faster or slower. Depending on the intensity of each force, it changes how the object moves in air. Weight. This force comes from gravity acting on the mass of an object on Earth. Everything on Earth has weight. In order to fly, an aircraft needs something to push it in the opposite direction of that of gravity. Lift. Lift is a force that acts against gravity and pushes an object to move up. This force opposes the weight. Any object that flies needs to have lift. An aircraft requires more of lift than weight to be able to pull up in air. Drag. Drag is a force that slows something down. It makes it hard for an object to move. Water has more drag than air, which is why it's easier to run in air than water. Intensity of drag can also vary depending on the shape of the object. Most round surfaces have less drag as compared to that of flat surfaces. Thrust. Thrust is a force that acts opposite to that of drag. It is a force that allows the object to move forward. An aircraft requires more thrust than drag to be able to move forward. A small aircraft gets its thrust from a propeller, while a larger aircraft gets its thrust from the jet engines. Theories for flight. The main theories for flight are Newton's laws of motion, Bernoulli's principle, inertia, energy, velocity, acceleration, equilibrium, three-dimensional motions. All of this will tell us what makes a flight capable of flying, rather what makes an airplane capable of flying. To begin with, Newton's laws of motion. Newton's first law states that every object persists in its state of uniform motion in a straight line unless it is compelled to change that state by forces impressed on it, which could be put in better words by saying that an object remains in its state of uniform motion in a straight line unless and until there's an external force acting on it. It is also known as the law of inertia. For an aircraft or taxi to fly, an external force must be applied to it. If not, the aircraft will remain in its state of rest. Similarly, once the aircraft is moving, another force must act on it to bring it to a stop. This willingness of the object to remain in the state of rest or state of motion is referred to as inertia. Here's a little example. When flying at a constant altitude, the aircraft holds constant airspeed. To be able to hold constant airspeed, the thrust should be equal to your drag. Now, here, if thrust increases, the aircraft accelerate, so the airspeed increases. And if drag increases, the aircraft slows down, so your airspeed decreases. Now, when drag is equal to thrust, the aircraft is no longer accelerating, which means it gives it a constant speed, which puts it at a constant rate of motion. Now, if you had to take this off the constant rate of motion, you need to apply more thrust than the drag. One component has to increase. If you want to bring it to a stop, your drag must be greater than your thrust, which is these extra components is your external force that either makes the object move forward or brings it to a stop. Newton's second law states that the force is equal to the change in momentum over change in time. Now, as we know, change in momentum over change in time is acceleration. So therefore, what they state is that The Newton's second law says force is equal to mass into acceleration. The more the force, the more the acceleration. If an object moving with a uniform speed is acted upon by an external force, the change of motion, which is acceleration, will be directly proportional to the mass of the object being moved. The motion will take place in the direction in which the force acts. Newton's third law states that for every action, there is an equal and opposite reaction. This action and reaction force can be seen when you jump off a small rowing boat into water. You will push yourself forward towards the water, whereas the same force pushes the boat backwards. This is one of the major forces or major theories used when it comes to flight. Another theory that tells us about how an airplane can fly is Bernoulli's principle. Now, Bernoulli's principle describes the relationship between pressure and fluid velocity. It's a statement of law of conservation of energy, and it helps explain why an airfoil develops an aerodynamic force. This principle is what allows birds and planes to fly. Bernoulli's principle states that when a fluid flowing through a tube reaches a constriction or a narrowing of the tube, the speed of the fluid passing through the constriction increases and the pressure decreases. Airfoil. An airfoil is the shape of a wing blade, which could be of a propeller, a rotor, or a turbine, as seen in the cross-section. Main function of the airfoil is to deflect the air. This results in a force on the airfoil that is opposite of that of the deflection. This force is what is known as the aerodynamic force. This force can be resolved into two components, lift and drag. The turning of the air in the vicinity of the airfoil creates curved streamlines, which results in low pressure on one side and high pressure on the other side. The pressure distance here is hereby accompanied by a velocity difference, due to which the resulting flow field about the airfoil has a higher average velocity on the upper surface than the lower surface. Let's apply a bit of Bernoulli's theory in here. The shape of the wing causes the air flowing over the top to move faster than the air flowing under the wing, creating an area of high pressure under the wing and lower pressure on top of the wing. Equilibrium. It is a condition wherein all forces acting on a body cancel each other, resulting in a net force of zero. State of equilibrium in flight is when all four forces of flight cancel out each other, resulting in no force acting on the aircraft. This basically means that your lift force and your weight force are equal, and your thrust and drag is equal. So the airplane ends up moving in a straight line path with a constant speed. Three axes of movement. The aircraft is free to move in three main dimensions, which is pitch, yaw, and roll. The pitch is wing to wing, yaw is up and down, where roll is nose to tail. Pitch. This axis is also called the lateral or transverse axis. Its origin is in the center of gravity, parallel to a line drawn from the tip of one wing to the other. Motion in this axis is called pitch. A positive or clockwise pitching motion rises the nose of the aircraft while lowering the tail. Yaw. This axis of rotation is also called the vertical axis. It has its origin at the center of gravity and is directed towards the bottom of the aircraft, perpendicular to the wings. The motion about this axis is called yaw. A positive yawing motion moves the nose to the right. Roll. This axis of rotation is also known as longitudinal axis. Its origin is at the center of gravity and is directed forward. Motion about this axis is called roll. An angular displacement about this axis is called bank. A positive rolling motion lifts the left wing while lowering the right wing.